Okay, so today we start with the operational amplifier. Last week we already done field, okay? So before we start it, I just go over. So make sure you guys can understand. This is the op amp. One go to the negative and the other one input go to the positive. And that will be V out. Okay? And one go to the negative, we call it inverting. Input, and the one go to the positive or non-inverting. Input, okay, and the input between positive and negative we call a VD. So definition, VD equal V at positive minus V at negative. And they want VD equal 0. That only telling you all the time V at positive will be equal V at negative. Okay? And also the op amp will be get the power supply. One will be plus voltage and another one will be negative voltage. And the voltage power supply to the op amp will be from plus minus 8 volt up to plus minus 38 volt. So if you're using 15 volt plus, then the negative will be minus 15 volt. Or if you're using plus 12, and the other one will be minus 12. That will be telling you one thing. The output of the op amp cannot be higher than the power supply. For the AOL, you understand AOL? A stands for the gain. OL, open loop gain. That means when you get the op amp without any connection, they already get the gain. That gain built in from manufacturer. Okay? And normally for 741 op amp, the open loop gain will be 200,000. Okay? And also, when we're talking about the op amp, we're talking about input impedance and output impedance. Okay, between the input and the output, you get a big resistance inside. They call it Z in. And also when they're coming out, you get the one we call it Z out. So Z in, they want to be infinity O. So that's only telling you the current cannot go into the op amp. The thing is they get high input impedance. And the current coming out will be maximum. The thing is output impedance, they want it to be a 0. Okay? So any question regarding to whatever we already done? Okay? If it's not, then
Mr.
the other
Pham,
thing,
Mr. Pham,
yeah,
your AOL look like you got 260.
200,000.
Oh, okay. Okay.
Okay, also you can see you can get a VD. What that AVD?
The voltage gain?
The voltage gain
Voltage gain different.
of the differential. Okay? That is the voltage gain of the differential amplifier. What they equal? What AVD equal?
The output voltage?
Equal what? Just tell me the formula.
Yeah. V plus minus V.
Now, what? You say V plus minus V minus, that's the VD, not the AVD. A means the gain.
I think V out over Vn. Oh,
Okay, that's good. V out. Divide to what?
the difference between the two terminals of Vn.
You have to say one V,
Vd.
VD. Right?
Yes.
Okay, that's the definition. And also you can get another one, CM. What is the ACM?
Common mode gain.
Yeah, that is a common mode voltage gain equal basically they will be equal V out of the ACM. Okay, just divide to the V in of ACM. And you understand another one, CM equal. What is CMR?
Common mode ratio.
Common mode rejection
Rejection.
ratio equal what?
Equals AVD over ACM.
Perfect. AVD ACM. The thing is, if you want to understand, that's a very basic thing. You must be memorized. That's a very, very basic, okay? So also ACM you can calculate by dB using 20 log. Okay, now if you say I get it op amp here, what VL equal? I given the gain. What the VL equal?
Three
Now
million,
telling me.
3 megavolt.
Okay. Any other question? Any other answer?
Oh, that's a common mode. That means it's 0.
Perfect. They must be zero.
And- yes. Okay. Sorry.
That's okay. The thing is, whenever they look like both signal will be the same at the input of the op amp, they consider to be the noise, and the op amp will be rejected. Okay. So right now you see both input connect to the same 15 volt. So the op amp look like 15 volt like the noise. So they cancel out. Okay. And the other thing, make sure you have to understand the negative positive here. This is the one input and another one. And they must be opposite. Okay?
Phase.
If they apply the both input into the differential amplifier, they must be opposite. If they the same, op amp considered to be common, so they be rejected. Okay, so now we start with today. Okay, when you're looking into that thing here, they display the open loop frequency response curve. Response, that means output curve. Okay, that means for the open loop gain. And if you can looking into that, they can get the 3 minus 3 dB point. You understand minus 3 dB point. That means the critical frequency. Okay, the critical frequency or stop frequency. That means the frequency will be at that frequency, the output will be going down to 70.7% of the maximum value. Okay, 70.7% means 0.707. If you take 20 log of 0.707, you get minus 3 dB. Okay, you have to remember that. That means normally output of the op amp after the minus 3 dB, they don't want any more output. Okay, that will be limited. So if I'm looking into here, okay, so basically on the frequency domain will be in hertz. Okay, so if you're looking into that display, can you tell me what the bandwidth for this open loop gain here? What is the bandwidth?
It's 10 hertz.
Perfect. You can see that. That means from 0 up to here. That is the bandwidth. Okay. That means they only calculate the bandwidth up to the cutoff frequency. The cutoff frequency in here only 10 Hz. So that will telling you open loop gain cannot be working. The thing is they working only from 0 to 10 Hz. No way. Okay. And also, by the way, if you see they say slope minus 20 dB per decade, what that mean? What that mean when they say slope minus 20 dB per decade?
At the attenuation rate?
Right, that attenuation, but what that mean? Minus 20 dB per decade. Okay, if it's not, I'm telling you. That means
Region.
after the minus 3 dB, okay, and the gain will be going down at the speed minus 20 dB. Okay, minus 20 dB, if you take your decibel, so minus 20 dB equivalent to what number? You understand the 0.707 equivalent to minus 3 dB. So now if you get 20 dB, minus 20 dB, okay?
Going down
Okay.
roughly 5.
0 point, the number will be 0.1.
Or 9, I think.
Now you just take a 20 log of 0.1. What you get?
Yeah, it's negative 20.
Negative 20. Okay, so that's just telling you, okay, after the cutoff frequency, the output, they will be going down 0.1, okay, per decade. Decade means 10. That means the cutoff in this case will be 10 Hz, okay, and now 10 you multiply by 10, you can get 1,000. That means at the 1,000 Hz, okay, and the output will be going down to 0.01. Now, the first one we will learn it. They call it inverting amplifier. Okay. First thing I can tell you why they call it inverting. Okay. The thing is input VE. Right here. Connect to the negative. That's why they call it inverting amplifier. If they connect to the positive input of the op-amp, they call a non-inverting. Okay. And now, if you're looking into here, you can see you get a current flow this way. High. That will be positive. That will be negative. Okay. When this current goes to this point here, where they go. First thing is they cannot go into the op amp. No, not this one. The reason is the op amp will be high input impedance. Okay. Then they will be go up. And this positive and this negative. On this side, that will be negative. Okay. And this one here, how many volts on that point?
Zero.
Zero. Why zero?
Same as V1.
Perfect. The thing is you understand VD, right? VD equal Vs positive minus Vs negative. Okay, and equal zero. So Vs positive equal Vs negative. And this is the ground here. So this one also 0 volt. However, this one is special in the op amp. Okay, they get a name they call a virtual route. Virtual route. Okay, what's the difference between two routes? You get one route here, and also you get one route here. So what's the name for this route?
Earth ground?
This is ground, yeah.
They call a physical route. What that means for physical route?
It's connected to Earth.
It physically
Right.
physically connects to the ground.
Exactly. Physical route means you need a wire
Mhm.
to connect to the route. And the other one, you don't need any wire connect to the route, but they still be route. So that's why they get a virtual route. Okay? The difference is the current can go through the virtual route and go into the IF. Okay? So RF they call a feedback resistor between output and inverting input to produce low loop gain ACL. Okay. So we need to do some calculation here. Okay, you get R1, R2, load. Okay, R1, I given you 1K. R2, 2K. RL, 5K. Okay, that's what we call inverting amplifier. And this one they call a virtual route. Okay, the current going this way, positive, negative, and the current coming out here, positive, negative. So this is negative, and this have to be positive. Okay? So this current go into here. Where they go?
To R2?
To, yeah, they go to R2, but they go up to this point. Where they go?
Back inside the amp and also to ground through RL.
They cannot go through down. They cannot go this way. Going down. Why? Why that current cannot going down?
Because the output impedance is low, so they choose to go to the low resistance route.
They cannot go to the low. That's what I'm
Resist,
saying.
the current takes the path of least resistance.
No. Okay, this current going up to this point, they cannot going down again. Okay? What I'm said, they cannot going down. Where they go? They must be go this way.
Mhm.
Right?
Hey, Mr. Pham, is that the path of least resistance?
No.
Okay.
But my question still, why this current is not going down?
Mr. Pham,
Yeah.
why is the ground underneath the RL is positive?
The thing is the other side negative. Then the other side of
So-
the resistor must be positive, no matter
Because,
what.
because 0 is positive in regards to a negative number.
Exactly.
Okay.
So that's it. It's because the higher positive potential there, the electricity flows towards.
Lower. Okay?
That's what I meant.
The reason they're not going down, the thing is this is a negative. Why this negative? The thing is this is a negative. Okay? And the resistor RL, they get a one side negative, the other side must be positive. So they also get the current flow this way. That's what they call high load IM. That is the whole picture how the current can be flowed in the inverting amplifier. Any question or confusion, let me know.
So once it go into the off amp, it go inside, then where does it go from there?
Now they go inside the thing they op amp in this case they call a sink current. That means the op amp able to put in the current, or they can be sent out the current. In this case, they will be sinking current.
And Mr. Pham, where does the output then go? Like if it's going to inside to the amplifier, how does the amplifying signal where we are using it in this case?
The thing they do one, either they can put in the current in the circuitry, or they can sending out the current. Even they don't have any current coming in, but they still can have a current coming out. Sometimes you want to put the current in, okay? That means they put it to the route. Or sometimes you want it, they send the current out. That's what all the time. They can get a sink current or source current. In this case, will be sink current. And don't worry about why they sink, okay? Or why they can be shorted. You design, engineer then you have to know when they using the op amp. But in this case, the current will be go into the op amp, not going out. So if you want to calculate the V out, telling me how, what V out equal.
4-volt
looking-
RK, 5K.
V out equals R2 over R1 multiplied by the current.
Now, I want to asking you by looking into the circuit. What V out equal? V out, that means the voltage measured from the output to the ground, right?
Okay.
IL times RL.
Perfect.
Yes.
IL times RL. However, you see the minus side, right?
Mm-hmm.
You get that?
Yeah.
Okay, however, if you want to get the formula to calculation, you cannot using RL. The thing is RL not depend on the system. Like just stereo, you get speaker. Speaker, that means RL. At the low, they not depend on your system. You can change any speaker you want. Okay? So that's why we have to find another way. Another way to calculate V out, telling me what V out equal. I don't want using RL. I try to make sure you understand. V out means output measured from the V out to the ground. So what they equal?
R2 multiplied by I.
V in time gain.
Multiplied by I, right? You take the I times R2. That means you get the V out. Why? The thing is of this point right here,
The virtual ground, which is the
they
same.
also the this point right here, right? Also the route. So V out, they can measure from here to this route, and also from here to the other route right here. Okay? So they will be equal minus I times
Okay.
R2. R2, that's what they call a feedback resistor. Feedback resistor means the resistor connects from the output back into the input. Okay. Now, what I need to do is I want to calculate the I. What current I equal? Just look into the circuitry, tell me what I equal. That's what I call VE.
Yeah.
4 milliamps.
What I equal? Just tell me formula first.
V in divide R1.
Yeah. Divide
R1.
R1.
Or
The thing is you understand this round right here. Okay? So you get only one source, one resistor. Law. Okay? So now you can say V out.
Mr. Pham, I have a question here.
Yeah, go ahead.
So for the current, and V in over R1, what about the R2? Are they in series in this case?
No, This is, I said, this is, you understand again. This also
Virtual ground.
ground.
Mm-hmm.
So now you can get only one source. And you go resistor here, and you go to the ground. So that will be plus minus VE. This is R1. So the current flowing here, I. So that's just the overall,
Okay.
okay?
Okay. That makes sense. Thank you.
Okay. So V out now minus I say V in divide R1 time R2. You get that? So now you get the gain A. However, in this case, they call it CL. CL means closed loop gain. Okay? When they get a resistor connecting to the circuitry, the gain no more open loop gain. Now will be closed loop gain. So AOL, ACL equals V out divide VE.
Hey, Mr. Pham, is the closed loop gain, is the difference between the closed loop gain and the open loop gain R2? In other words, one is with that resistor and the other one is without that resistor?
Without any resistor.
Is which one?
No. You bought the op amp, you just get the op amp. They already get open loop gain.
Okay,
They already built in.
okay,
However, when you make a connection, now they will be closed loop
okay,
gain. Okay?
okay, all right.
So V out over V in will be equal minus R2 over R1. Okay? Or I get a little more detail here. I say RF divided by R1. ACL. In this example, I using R2. But that also RF. I'm telling you, in the circuitry, in the company, you never see RF. The thing is, in the circuitry, inside the company, they're using R1, 2, 3, 4, 5, only the number. Okay? They're not using RF. But you must know which one will be RF. Okay? So, to your guy, when you see the circuitry, you know that will be inverting amplifier. Okay? And what is the gain? They will be minus RF over R1. So in this case, you can see the gain equal 2K divided 1K. You get minus 2.
Mr. Fan, the letter F is a standard for follower here in this configuration?
Wait a minute.
Feedback.
The letter F is for feedback.
Yeah.
Okay, thank you.
RF, you know, I just talking about feedback resistor. We're going back to that circuit.
I
But
think
I try to explain here for you to understand everything regarding into inverting amplifier.
I think what he was also thinking, Mr. Pham, R2 and RF in this case is the same thing.
Exactly. Instead, they using RF. That
Right.
means feedback resistor. In this case, I don't care RF. I just put R1, R2, R3, R4. Make sure you understand. In the schematic, in the circuitry, in the company, never see RF. Why? The thing is when they build resistor, they have to say 1, 2, 3, 4, 5, up to 50, for example. So if they looking into the last resistor 50, that means inside circuitry they get 50 resistor. Okay? 50 resistor. Okay? However, you must understand RF just a feedback. Feedback resistor. Resistor connect from the output back into the input. So in this case, the gain equal -2. What we have?
-8 volts.
Perfect. That given to you. V out equal -2 times 4 -8 volt. That's why they go inverted. Input positive, output negative. Input positive, output negative. Input negative, output positive. Okay? However, if I changing that one here, I change to the sideway AC. Okay, I can say V in equal 5 volt peak to peak. What we have? If I change to the sideway AC signal, 5 volt peak to peak, what is V out?
It is your V in times your feedback resistor divided by your
No, we
input.
already do it. We already calculated. The gain equal -2, right?
Right.
So the output is -10.
Okay. So that's what I asking you. You say -10. That's what you say -10. Who knows if it's right or wrong?
It's an AC signal, which means that it's flips, positive, negative. So I'm not really sure about the output in this case. I don't think it's minus.
Okay, now they cannot be say -10.
Mhm.
The thing is AC. So you can say equal 10 volt.
Mhm.
Only thing is, if
You can
your
say 10 volts because it's actually either minus or plus, because it's AC, correct?
no, let's say this is your V in. Now you say output will be a 10 volt peak to peak. That only thing telling you output they will be opposite.
The exact opposite. Yep.
Yeah, that's for minor. Okay, for DC, okay. However, for AC, you cannot say 10 volt peak to peak, that's wrong. They have to be 10 volt peak to peak. However, they will be out of phase, opposite. Okay, any question?
So they will be opposite depending on the input.
Yeah, out of phase.
Okay. Okay. Thank you.
Mr. Pham, I have the equation here for AC operation of an inverting amplifier. V out equals V in times R2 divided by R1.
V out equal
V in peak to peak times R2 divided by R1.
yeah, that's what we get right here.
Okay.
I think where he's getting that from is because you have the feedback resistor, which is R2.
Okay, now we will go faster here. Okay, now this is will just try to helping you. Okay, when you're reading, you already understand. Okay, and how to get a closed loop gain and everything. Now for this circuitry here, current I will be equal V in divided to R1. V in 5 volt. R1 is 1K. So that's why you get 5 milliamp. Closed loop gain ACL equal minus RF over R1. So this is, they say R2. However, this supposed to be RF. For this circuit. So you get 1.5K divide 1K, you get minus 1.5. If you want to calculate the V out, you take the ACL times V in minus 1.5 times 5 volt. You get minus 7.5 volt. And if you want to calculate the load current, you take V out, divide to 5K. Okay, you get 1.5 milliamp. And finally, if you're going to calculate the total current of the op-amp, then you take I plus IL. You get 6.5 milliamp. That covers everything regarding into the inverting amplifier. And make sure the point right, this point right here, they call a virtual round. Okay? Otherwise, they're asking you, you don't know. That's a virtual round. That's a different from physical round. They don't have to get a wire connect to the route, but they still 0 volt.
Hey, Mr. Pham, if I could just ask, the virtual ground is where that arrow is pointing from the ground up towards the red dot, correct?
Yeah, that means they're the same. The thing is they say the different voltage here is 0, right?
Right, okay.
So that route here means the same route here. That's it. Okay, any question regarding into the inverting amplifier? If you understand that, are really very easy. Now you do this for me. For this inverting amplifier, okay, the first thing they want gain ACL. Okay,
The minus 10?
yeah, do it now.
I got minus 10.
Okay, so 10K divided to 1K minus 10. Correct. V out. So you need to know what the current. V out will be equal V in time gain. Okay, V in is 1 volt.
1 volt.
And then that means V out equal
10.
10 minus 10. Current I. You get V in at 1 volt. R1 is 1K. So you take V in divide R2 in this case. 1 milliamp.
1 milliamp.
Yeah, 1 millivolt. Or
No,
1
1
milliamp.
milliamp.
Yeah, sorry.
Yeah.
Load current.
Yep.
You calculate the load current. You take V out divide to 10K. V out divide to 10K. V out is 10. Divide to 5, 10K, you get 1.
1 milliamp again.
Total op amp current.
2 milliamps.
Perfect. That is the answer. That normally they will be asking you. Okay? They don't care how current flow, whatever. They just want to get through the answer. Any question?
Mr. Pham, the op-amp current 2 milliamp, is that because we have the 1 milliamp from the R5 and the other 1 milliamp from the input?
From R3.
R3, okay.
Mr. Fan,
Yeah.
do we have the gain closed club from the procedure, the manufacturer? They
The
give it.
gain from manufacturer.
Yeah.
that only you get open loop gain.
Oh, yeah, yeah. Open loop gain. Yeah.
Yeah. When you connect into the circuitry, they can be closed.
And
Hmm.
Mr. Pham, so there's only one milliamp flowing through that R3, is that correct?
Right.
Okay.
Okay, now they want you guys try one more. Inverting amplifier again. Okay, first thing before you do calculation, I can telling you. This your input here. This your output. Now you can see input output will be opposite or off phase. Right?
Right.
In go up, out going down. Okay, so you cannot get any negative sign in there. So first thing, they want you to do a telling what the ACL closed loop gain.
-3.
Negative 3. 4.5 divide 1.5. What you get?
3. -3.
1.2.
-3.
You
Yep.
get minus 3.
Yes.
Okay, what we out?
3.6 volts.
Okay, 3 times 2 is 6. 3 times 1, 3.6. No negative, okay? The thing I did, it will be a AC. Current I to R1. So they will be equal 1.2.
2 divided by
800 millivolts.
1.5.
I'm sorry, 800 milliamps.
Is it 1.2 divided to 1.5?
0.8.
800 milliamps.
800?
Yeah, 0.8. Yep.
Yes,
800.
sir.
Milliamp peak to peak. That means they still sideways.
I'm sorry, Mr. Pham, what do you mean by sideways? I got
Sine
confused.
wave.
Ah, sine wave. Okay.
Sideways.
I was thinking, what
Sorry.
is that?
Sorry.
Yeah, sorry.
Sideways, right?
Yes, yes.
That correct me. Don't worry about that.
Sorry.
Okay, now that will be non-inverting. We recognize non-inverting. The thing is input, this the input here. Connect to the positive. Okay, so that's non-inverting. However, this voltage here is not a V in. The thing is they not connect directly to the positive. So the V in must be right here. That is the voltage divider. 5 volt times 1K divide 1K plus 1K. You get 2.5. So right here is 2.5. Okay? That is really input to the op amp, not 5 volt. Okay? Now, my question here, what voltage here? what the voltage at that point?
2.5
Perfect. 2.5.
because similar inputs.
Why 2.5?
Because the op amp has like similar input, like the two terminals, they have to match the voltage.
Right here, you have to say right here.
Okay.
The thing is, the difference between two input will be no different. No different. They're telling you to get a 2.5 volt in here. Then also you get 2.5 volt in here. That is explain why you get 2.5 volt. Okay, now.
And
you
Mr.
can
Pham,
see-
just real quickly on this one here, you don't have a virtual ground?
No. The thing is,
Okay.
it is not connected to the route.
Okay.
Not, they're telling you it not mean every time this right here will be virtual. No. Only thing is when they connect to the route, then they can be virtual. Okay, now you get 2.5 volt here, you get down here. So you can calculate the current flow here. Okay, that current I equal 2.5 divide 1K. Okay, you get that? This is your short here and round here, Ohm law. Okay, 2.5 1K. And this current, they cannot coming from here. The thing is, the op amp have no current in here. So that is not here. But they will be coming from output here. Okay? And the positive here and the negative here. Okay? So this current will be go to this point. Then they cannot go into op amp. Then they will be go to R1. So by looking into the circuitry, tell me what we are supposed to be. V out means the voltage at the output to the route. So just look into the circuitry, tell me what V out equal.
IL multiplied by RL.
IL. Yeah, you're correct, but we cannot using IL for the formula.
Hmm.
Then what V out equal?
I times RF.
I times RF, that's correct. Then what else?
Plus R1.
Okay, basically they be I times RF. That means from here to here. And from here to round. Adding I
IR1. Yep.
times R1. Okay. Or they can be I, okay, RF plus R1, right? Is it correct?
Yes.
Yes.
Okay. What I equal?
V out over
That,
RS plus
that
R1.
we using V in, okay?
Oh, I'm sorry.
V in. Divide to R1.
RF plus.
Okay, so I substitute I into this formula. V in divide R1 time RF plus R1. Okay, and now I take the gain ACL definition V out divide V in. Okay, V out divide V in, so they can be 1 over R1 time RF plus R1. And then they will be equal. R1 cancel. It get 1. So they will be 1 plus RF. That is the formula. Over R1.
Yeah.
Okay? So right here. Again, for this non-inverted, will be 1 plus RF over R1.
Mr.
If you know
Fan,
RF, you know R1. You can calculate the gain. And after you get the gain, you can calculate the V out. And now you can see the current here, basically they want coming out, I. Another one current will be go to the load, I load. So output of the current of the op amp will be equal I plus IL. That's everything covered in here. Okay. So finally, closed loop gain always greater than 1. That's easy to understand. The thing is they equal 1 plus 1 plus whatever. Then they must be greater than 1.
Hey, Mr. Pham, in that current that you got on the output, one of them goes from the output up towards the feedback resistor, and the other part of the current goes down
Right.
towards the load.
That's what they call a source current.
Okay.
Mr. Fan,
Yeah.
regarding the same question, current is flowing from the 5 volts into R2 and then down to R3, but not into the op amp. Then on the output, the current flows exactly the way your arrows are displayed. Question is, what component inside the op amp is
Yeah.
causing that current flow direction?
Okay. Now asking me what inside op amp.
You don't know, Mr. Pham?
Well,
I don't know. I don't care.
well, just all right. Just to keep us entertained. If the voltage is supposed to push the current, right? Can you provide us a hint as to what is causing that current to flow out of the op amp because of the voltage?
Now, depending on the configuration of the op amp, if you want to be a non-inverted, current will be going up.
But there's a load inside that op amp that's kind of generating the current because of the voltage.
No.
All right.
I read that thing.
No details. All right.
The thing is you want to know what's going on inside.
Well, that when I simulate it, that's exactly what's happening. Is you don't see the current going into the op amp; it's only coming out. So
Yeah. If you build this way.
The secret's inside the op amp. All right.
Right. If you want to invert it, you can see the current coming in.
Hey, Mr. Pham, in
Yeah.
your in your world of engineering, like you're an engineer, but you deal with like you deal with like building things, and then there's another engineer that deals with what goes on inside the different electronic parts. Is that correct?
Exactly.
Okay.
That is the manufacturer, they build the op-amp. That's a special engineer just working inside. We're using the application. That means how can we using op-amp to do what we want to do.
Right.
If they hiring me to working on that, then I could do it. I will do it. So let's see. Okay, do this example. For this circuitry, F1K. That will be 1K. Okay, R2 1.5K. And V in minus 2.5. Okay, they want to know number one, gain. Go ahead, calculate quickly, telling me what ACL equals. You know, ACL equals
1.66.
1 plus, right? RF over R2. One plus over 1.5 plus what?
Is the answer 1.66?
Yeah. You get 1.66, right?
That's what I got.
Yes, I got the same answer.
Yeah. V out.
4.16 volts.
Okay, 1.66 times minus 2.5.
Minus.
Oh, negative 4.16. I'm sorry.
So you get 4.16, right?
Yes, sir.
Negative.
Number three, current through R2. Who can get for me?
It's not 1.66 milliamps, is it?
$1.66 milliamp.
I got a 1.066 million.
How do we calculate IR2?
V in divide
That means the
R2.
voltage here, okay, What the voltage here?
Yeah, 2.5.
5 volts.
That minus 2.5, right?
Yes, sir.
Right.
Okay, so 2.5 divided 1.5.
Yes, sir. That's what I did. 1.6 million.
1.066.
I don't have a zero.
You take the 2.5 divided 1.5. Your calculator.
I did 2.5 divided by 1500 just so I could get it in milliamps. But 1.66 is what I got. Yes.
That's what I get.
I agree with you, sir.
You see, op-amp is more easier than the transistor.
Now, is the voltage going to be a negative soon, or is it positive?
No. Voltage will be negative. However, current never.
Oh, currents never. Okay. All right.
By the way, I can telling you. When they get resistor here and the current flow, they say I equal 1 ampere. Okay, that means the current flowing positive to the negative. However, when if you calculate it, you see your guy get the current equal 1 minus 1 amp. Okay, so the current cannot be negative. So in this case, they just telling you the current will be go the other way. Okay, remember, current have a no negative value. Okay, then this one, then we go. So you're looking into this circuitry here. You can see non-inverted. V in 2 volt peak to peak. Okay. So what ACL equal?
23.
ACL 1 plus RF what?
Yes, 23.
23?
Yes.
Okay. If you want V out, take V in time. Okay. Is it 46?
46. Yes, sir.
Now they want the current flow here. I out in. What that current?
Two and 3 milliamp.
What you get?
20 milliamp.
How many?
20 milliamps.
Okay. 20 milliamp. Okay. So I equal 2 volt
I got 200 millivolts.
divide 10K. Okay. So the answer will be automatically milliamp. I think that's 0.2.
Or am I reading that wrong?
When you divide voltage to the kilo ohm, automatically you get milliamp.
Unit conversion.
Yeah, you don't have to. Remember, divide voltage to the kilo, automatically milliamp.
Okay, yeah, all right.
That's easy. Okay, I want you to see on that one here, value of Rf. Okay, so you can try that. We will be start tomorrow at this problem here. Okay, they given to you what they give. They given to you the gain minus 100. They given you 2.2K for the R input, and they want to know what RF. I don't know. Okay, so that's it. We'll be seeing you guys tomorrow. Make sure tomorrow you have to also download. That's what I'm telling you at the beginning. Will be active filter.
I'm sorry. Can we put that in the chat? Sorry.
Okay, I will be just a minute.
Thank you.
I will be stop this here. Okay, I can let you guys know. Okay, whoever not download operational amplifier, then you have to download it, and also active filter. I try to get all of the major lecture for the electronic done on November. Then we can get December and January. Try to review everything we need for the technician.
Okay.
Okay.
Yeah.
Any question? Anything?
Thank you, Mr. Fan.
Yeah, we'll see you guys tomorrow.
Thank you, Mr.
Thank you.
Good night.
A question on regarding of the Tech 2, the list Sam sent out.
Tech Joe?
Yeah.
What happened?
The list of component Sam sent out, you want us to go ahead and just purchase that right now?
That part that I send up, it's up to you. If you want to build your circuit, if you want to build it, yeah, you can go ahead and purchase those components. Mainly I purchase those components myself when I use it to do my lab. So I purchased mainly from Jameco. So if you can find anything else at different pricing at different places, that's fine. You can buy it from either eBay, from Amazon, or any other places that you can get the component at a cheaper rate. But the pricing that I gave you, that's the listing that when I went through it, that's when I found the pricing for it.
Okay. And then what about when we apply the voltage? I guess, the whole purpose is where we can apply the voltage. And
that is what I'm doing right here. So this is actually your lab, D lab 1.
Okay.
D-Lab 2, D-Lab 3. I built it here, and this is the D-Lab number 4 right here.
Okay. Now, how do we?
So this is my so this is where it is. So I'm going to be. This is the box. This is the control box, and it has the power, and then it has a USB cord that is connected to your computer. Okay, and this is connected to here into the to the control box, and the control box would be able to send out the power supply through this connector. It's a 4-pin connector. It has a red, which is a 5-volt, and the black one is a common. It's a black one. And so this is going to be hooked up to your board. So this is the board that I built for D-Lab 1, for example. D-Lab 1 using port A and port C. So therefore I have control box. I look at my port A. So this is my port A. I connect into my port A. And then port C, it's going to be this is port C. It says label on it. So I connect it into port C. And then this would be my power supply to connect into the power supply.
Okay.
And so that is connected to the power supply. And then after that, once that is set up, then I would go to let me go ahead and go to share your my computer screen share. Okay, so from here, I will be running your software, okay? So therefore, if I go into open up my Visual Studio. Okay, can you see my Visual Studio?
Yeah, I can see
okay, so I go through, I already set up your I already download your information from the website. So therefore, I'm going to go in here and I put it, so this is Fault Tech 2 and your C++ student. And then, so this is, okay, Michael, you will be there. And so D-Lab 1. So if I open up that file, and that would be, the program would be here. Okay, so this is with yours and with all your names on here and all the program it's telling me. Okay, so now that I have that, so this is what I set up. So this is so that is connected to there. That is the box is it's responding to the computer when I hooked it up. And then from here, I just go through and run. And so I built this to compile, make sure it's compiled, there's no error. Okay, there's no errors. And then after that, I can run it. And so I go to debug and start without debugging. Now I just, oops, let me see, that's still not finished. Okay, now I start without debugging. Now it will go through the testing. Okay. Let me see, where is my debug window? Okay, so this is my debug window, as you can see.
Okay. And it'll go through each one.
Go through each test, yes. So properties, let me see, 28, make it a little bit bigger.
Yeah, no, I can see it, yeah.
Okay. Oops, let me see, it stopped.
No, it's still going.
Yeah, it was, yeah, because I.
Hey Sam, that box, what kind of a protocol is using to upload the code in our circuit?
You copy, you paste into your copy, and then paste it into your Excel.
Yeah, but I mean, when you upload, when you transfer the code from C++ to the circuit that we're building, which kind of protocol is that? Is a kind of GTAG?
You follow the same program that Mr. Pham gave you in the class, right?
Yeah.
He did go over you how to write this program, right?
Right. Now, Sam.
Yes.
I can see the process how you know, with the code and then with the board, you know, if we build it, then you know, if we had the control box,
yes,
and we can do the test ourselves.
Like I said, it's still Mr. Pham still need to put that together. He still need to put up a procedure for that whole process. Right now, like I pass out those parts to you. If you can afford to purchase it, I go ahead and purchase ahead of time, because if
Okay.
I need to build my board and run the test,
Okay.
everything else, will probably can work with you. But if you don't want to spend the time to do that part, then there's no point of we have limited parts that we can lend out, but that is still up to Mr. Pham. You still need to go through the protocol of how to handle that.
Okay. So are we gonna build that control box ourselves? And
Okay, now
no.
you cannot build it.
Okay.
Okay. What we planning to do is when I can able to get into the class.
The lab, yeah.
Okay. Then I will be for tech you. Will be setting up everything for you in one box.
Mm-hmm.
That including on the tool, on the test box, okay, on the wiring, on the part number for your guy to take out to working at home.
Okay.
Okay. That means at home you can build and you can run the test. And we will be verified online with you.
Okay.
Okay.
Yeah,
that is the process we'll be doing. I hope after next week something changes.
Okay. So if we do go ahead and buy the board and all the component ourselves,
then you can do whatever you want.
Then
yeah, just like I did. I purchased all my parts.
And I
purchased my own parts, and so I can build it.
Right. But then I still need to wait for when the lab open, then I can get the control box on loan so I can test my circuit.
Right.
Okay.
Hey, Mr. Pham and Sam, if I could jump in, for those ones who want to buy stuff, they should probably like get together as a group, because for those who don't know, the electronic companies make money when they sell a lot of stuff, not when they sell little one parts or 2 or 3, 5 here. So that's the better way to do it. Group up with somebody who want to buy stuff and then purchase it that way.
Now, the thing is we cannot get together. Okay? If we cannot able to get together, then I can let your guy take out.
Oh, I see.
You don't have to buy anything.
Okay.
Only thing I want to do your job.
So, excuse me, Sam, where is that the list? Where did you put the
This is my own list. I compile it for myself.
Okay.
When I went through the class, and these are the parts these are the number that I as this one was the pricing, as when I purchased this was back in May of 2018. So the price has changed because of COVID, and so most of these may have gone up quite a bit, because I was looking at this one was like $9 a piece.
Got it. But there is a chance that you can share that list with us?
You have the print. I'm showing on the screen. So do you print screen, or are you seeing it on your side or no?
Yeah, we see that what half you're showing right now.
So you can do your print screen, or you can do what you need to, and so you can have the list.
So Sam, since we're doing it at home, how critical do you think it is to go for the 3220 tie points versus like 600 less?
Well, the 600 less, that one you're going to be depending on how complicated the final circuit is. If he goes with the with at least 17 ICs, you won't be have enough room on your the one with 600 less.
Just asking because I saw it was a little cheaper.
Yeah, it's cheaper, but we're using the full board, and like I said, when we get into building the final circuit, it require all that.
Oh, I'm so excited.
Yes. Yeah, so it requires all that space. So therefore, let me scroll down a little bit more.
Thank you very much.
And so there is the second set. So this is the tools. So these are the tools that the one that I found. you can go to circuitspecialist.com, and that the board is only $16.85 circuit board. On Jameco, it would be a lot more. It's like close to $40.
But the thing is, you buy one, they not ship it.
No, because you're buying all these parts listed together, total. They will ship it. I purchased them.
Yeah, shipping, I figured it out, it's about $12 something if you
Yeah,
buy.
they will ship. Yeah, right now they'll ship. You place the order.
Could you please show from row 26 to the end of the first list, Sam, please?
And then where it says like three different options for the breadboard, it just means we pick one of those. They're the
Yeah,
same, or
you
we need
want
three of
to.
them.
Yeah, you shop around for whatever it is, but it's this one. It gave you exactly the name of it, and that's what it was defined on the board. I copy exactly what they listed under their company, and that's what they described it, and so therefore I type exactly how it's written, and there's their manufacturer part number, and so I'd recommend getting just one of those, and here's one here, and one here, and the wires you might be needing about 4 of those. So now this one is 100 feet, so 400, so it's about total 4 of those, so total about 400 feet. Like I said, most of these, if you can afford it, go ahead and purchase it. If not, then we still have to work with Mr. Pham to get the protocol to get that. But pretty much, I will be the one that's building the circuit here, and you guys are the one had to do the Excel, make sure it passed, and make sure you do your software, and then copy that, and then put in your Excel, and upload that into the website.
When to get it by?
Wait, I'm so sorry.
Hey, hold on. This is
Matt.
this is only for tech. This is only for tech 2.
Myself.
Hold on. This is only for
a latecomer here. Sorry.
This is only for tech 2
I
only.
just actually have a question. If we could actually get a copy or a recording of the meeting, if possible, or a copy of the slides, or whichever.
This I'm talking right now. We're talking about tech 2. So this is only applied to tech 2 student.
Oh, thank you.
So this is only applied to tech 2 student.
Yeah,
so
we will get more on Wednesday.
Yeah, so this is only tech 2 students. So this is my personal list that I compiled when I went through and did this class. Okay, and then let me see. This is where I go through and find out. Here's a circuit specialist. They have these. So here's the wires, a 22 gauge solid. So there's as you can see, the pricing is listed on there. So like I said, you can go there, and this one is from Jameco, and I can, as you can see, the listing of the wire here. This one is also 22 gauge. It's if you buy one, it's $8.95. Okay, and then I can go list now. I went to look at some other place too. This one
that is great. Thank you very much. And is it possible if you could put in the chat again the email?
Matthew, can you mute your speaker?
Okay, so this is this also I found this one in Amazon.
Or you could
now
individually send it.
I did purchase this one before, which is come in 4 wires. It's like it's about 500 feet. So 500 times 4, that's 2,000 feet. So you can share with your classmate or share with your friend. If you purchase this, you can split up that, some of the wires that share with your, if you buy this one in combo. But if not, you can buy this one, which is a coming set of 100. Okay, so those are the places I found: Jameco, Circuit Specialist, and Amazon. You can also find on eBay if you do some research on it. And these are, like I said, this is my own personal list that I compiled just for myself. And like I said, this was the pricing when it was back in 2018, before the COVID So now I see that I checked it earlier. This one was that pretty high. So you can search on eBay. Maybe they can have something a little bit cheaper. But this is a listing price as from Jamco. Okay, all this here.
Okay.
But you
so
can
this
also
will be-
find some of these. Yeah, you can also find some of these parts in Circuit Specialists. All right. All right.
Okay, so this will be in the recording today. If you want to see it, you can tomorrow. You can see it.
Thank you.
Yes, yes, that was me. Thank you. Okay, thank you.
Thanks,
I'm
Sam.
actually
Thanks, Mr. Fan.
working on a startup, nothing to do with the autonomous vehicles, but it's to do with the
Fam, you want to mute?
small scale at the beginning, but a larger scale medical device.
Okay.
Sorry.
So that's pretty much it.
This is okay.
Yeah, talk to
This
your
is
guy tomorrow.
Bye-bye.
Bye-bye.
Busy,
Bye-bye.
and
Bye-bye,
I have been
bye-bye.
attending
Thanks again.
actually earlier the delicious ones at the I forget the name of that joint that we used to meet at, but we'll give yes, Emiliano's that was actually good. But I'm glad that we are able
You
to
can kill
get
the power,
started
Mr.
here
Pham.
again,
Okay.
regardless wherever it is online. I work on a medical device. I'm an engineer by background, and right now working on my startup in San Diego. That's it.
Okay. So
Are you
good night.
hungry?
Good night.
Night.
Bye, Mr. Fan.
Definitely, yes. And I